Hello and welcome to Summer Institute Day 2. This video will be an introduction to algorithms. By the end of this session, you should be able to identify the building blocks of algorithms. This is our sequence, selection, and iteration. You'll be able to explain how flowcharts and pseudocode can be used to express algorithms. You should be able to write pseudocode to represent a basic algorithm. So a simple way to think of an algorithm is simply the steps to complete a task. You encounter algorithms all the time. A common place to find an algorithm is in a recipe. It's a step-by-step that allows you to complete the task of cooking. Your algorithms can start in a different form on paper and ultimately be transitioned into code. Slightly more complicated definition of algorithms would be the set of steps needed to do any task on a computer. It's called an algorithm. Code.org says an algorithm is a precise sequence of instructions for processes that can be executed by a computer and are implemented using programming languages. So there's three fundamental building blocks of an algorithm that we are going to discuss today. First one is sequence. It's a set of instructions that follow one another in order. There's an algorithm concept known as selection. A conditional is a form of selection, and it's a statement that only runs under certain conditions or situations. And lastly, iteration is a building block of algorithms. A common form of iteration is a loop, where you can repeat a sequence of instructions. So to go through those in a little more depth, sequence is the specific order in which instructions are performed in an algorithm. A common example of an algorithm sequence, step-by-step, that you probably encounter at least once a day is tying a shoelace. I'm going to play this video for you so you can get a basic sense of a sequence algorithm.
Want to know how to tie shoelace in 2 seconds? You won't believe how simple it is. This is how we do it fast. Now, we're gonna slow down and show you every step. First, tie your laces as usual. Then, put 2 little fingers underneath. Now, your right pointing finger and the thumb goes under the shoelace and left goes over it. Grab the opposite loops at the same time and pull through tight. Thanks for watching.
Alrighty, that was an algorithm, a sequence algorithm for how to tie a shoelace. The second building block of an algorithm is the idea of selection. And selection allows us to include more than one path in a program. So if your program comes to a place where it needs to make a decision on should it do one thing or should it do another, selection allows us to build that into our programs. So a basic way to think about it is selection allows the program to make decisions. So for example, if a program was trying to tell you what to do if it's raining, code might look something like, if raining is true, you would do one thing. If raining is false, meaning it's not raining, you would choose another. We can represent that on the left as an example of pseudocode, and on the right, it's an example of a flowchart. Those are two different ways to express algorithms. So a form of selection algorithm, a very common form, is what's called conditionals. We sometimes call conditionals if statements. So if this, do this. If that, do something else. Here are some basic selection statements to show you an idea of how selection might show up in an algorithm. You might ask, or a program might ask, if it is raining, if it is raining is true, then I need a raincoat perhaps. If I'm hungry is true, then I should eat. If the traffic light is red is true, then I must stop. Selection statements also will contain an alternate path. So oftentimes if something is not true, so if it is raining is false, then I need sunglasses. If I'm hungry is false, then I should take a walk. If the traffic light is red is false, then I must drive. The third building block of algorithms is iteration. iteration is a process of repeating steps. In algorithm or in a program, you'll find iteration anytime you have a piece of code that you want to repeat or loop. So again, the three building blocks of algorithms: sequence, selection, and iteration. There's two basic ways to express algorithms outside of code. They are pseudocode and flowcharts. So pseudocode is the act of writing computer instructions in plain language. Basic example might be when the program starts, loop forever, the conditional if the spacebar is pressed, then move up, or else move down. So you'll notice that this is written out in natural language. And when we've thought it through in natural language, it helps us move into the coding part. So on the right side of the screen, you'll see an example of some code in Scratch, which follows directly from the pseudocode. So we want to do a problem together. This is something you're going to get to work on yourself for a couple minutes. So here's a challenge. In pseudocode, your challenge is to write an algorithm for how to calculate a dog's age in years. So you want to write this in natural language. You don't have to code anything. You're just going to take a piece of paper, or maybe in Docs or some sort of document. You want to type out a couple steps for this in pseudocode for this algorithm. When you're writing this, consider two main things. What are the inputs? So when you're trying to solve this problem, what data do you need? And what are the outputs? Once you collect the data, what will be the result of your algorithm? So again, take a couple minutes. We're trying to calculate how old your dog is in dog years. So what are the inputs? What information do you need to figure that out? What are the outputs? What will be the result of your algorithm? This could be done in pseudocode in about 3 steps. Feel free to write down on pen and paper or use some sort of digital format. I ask you to pause the video right here. Take a couple minutes. Think about how you could write an algorithm. Remember, that's the steps to solve a problem for calculating how old your dog is in dog years. Alrighty, we're back. At this point, we're trying to figure out how old your dog is in dog years. We wrote out a couple of steps. We could have done it on pen or paper for identifying the inputs in our algorithm and the outputs. So a basic algorithm for figuring out how old your dog is in dog years is, first of all, you need to find out how old the dog is in human years. That might be an input. Second of all, you want to multiply the human years by 7. And third, you might want to print the answer to the screen. That's the output. That is the result of the algorithm. So as we said before, there's two main ways we want to cover to express algorithms. The first was pseudocode. You just did an example. The second is flowcharts. So an example of a flowchart is here on the left, and it represents the flow of a program and the decisions that are made within a program. So it starts with this program is trying to figure out which course is the best. The input asks which is the best subject. It then asks the program to make a decision. Does the answer equal computer science? In which case, it will output try again and loop you back to the input. If the person gives a correct answer, which is computer science, it will be, of course it is, and the program would stop. The question that we asked before about dog years can also be represented in a flowchart. So the start might be, might ask how old is your dog? So we need that input, which is the data to start our program. We'll do a basic process of turning the dog years into human years, or rather, we'll probably get the human years and multiplying by 7 to get the dog years. The output will tell you in dog years your dog is aged, and that's represented by the flowchart. Some fun algorithms represented in flowchart form. You might know about the hokey pokey, where a program asks you to put your right foot in and asks you, has your right foot previously been in? And if no, you want to take your right foot out. And then you put your right foot back in, and you got to shake it all about. So you'll follow the flow chart. Yes, it's previously been in, so you want to shake it all about. You do the hokey pokey, and you turn yourself around. And that is what it's all about, my friends. Algorithms represented in flowcharts can be a bit more complex. This is a flowchart to identify if you are a cat person. So it is a series of questions that lead to a result, an output of whether or not you are a cat person. Some questions and decision points that might lead to that answer. Another problem, we're actually just going to go through this together, is now we tried to figure out how old your dog is in dog years. This problem is to figure out who is older, you or your dog. And so if we were trying to figure that out, we could set up a flowchart solution. So we need two inputs: how old is your dog and how old are you? And then we need to take the dog years and transition them into, or rather take the human years and transition them into dog years. Will give us an output of in dog years, your dog is aged, how old your dog is overall. And then the question is your dog years in human age, your dog's age in human years greater than your age? And the output will either tell you the dog is older than you or the dog is not older than you. So that's how you might answer that problem with a flowchart. Okay, we are at the end of this session. Here are some things that you should be able to answer when you move into the sort of review quiz for the session. Number one is you need to be able to identify the building blocks of algorithms, or three that we've covered. You need to identify the two methods that we covered that can be used to express an algorithm. And lastly, why, we didn't go over this explicitly, but why might it be useful to do a paper run of steps? So to either express your algorithm as a pseudocode or in flowchart before you start coding. There's not a one right answer, but we are interested in your thought process. Thank you so much. Have a great day.